Hello everyone, I welcome you for week 4 of Mechatronics and Microcontrollers course. In this week, we will be learning about 8051 programming. We will be having a small introduction to 8051 programming. We will learn what are assembler directives, what are the different addressing modes of 8051, what are the different instructions available in 8051 for programming the controller, and at the end we will see few programming examples. If any task has to be performed, then the microcontroller has to be programmed to do that particular task. Writing programs to the microcontroller is nothing but programming the microcontroller to do that particular task. Program is considered to be a set of instructions or commands that will tell the microcontroller what it is supposed to do. The program what we are writing for a microcontroller can be written in machine level, that is in terms of zeros and ones, in assembly level language in terms of mnemonics, or in a higher level language like C or C++. 8051 can be programmed either by using assembly level language by writing the mnemonics or by using C. An assembly level language can be treated as specific to the physical or virtual architecture of that particular controller or a processor. Assembly level language is harder compared to higher level languages, but we use it whenever we want higher efficiency. If we are trying to control and communicate with certain peripheral devices, then we usually use assembly level language because there are special instructions available for this particular purpose. In a high level programming language, the programmer need not be concerned about the internal architecture of any microcontroller or a microprocessor. The assembler is the one which converts the assembly level program into machine level program. Instructions written for the assembler are called as assembler directives. Here are some of the examples of assembler directives used in 8051. The ORG or the origin directive, EQU equate directive, DB define byte directive, and END end directive. Let us see what each of these assembler directives are. ORG or the origin directive. It is used to specify the memory location where the first executable instruction of the program is placed as soon as the code is loaded into the memory. So for example, if I tell ORG 8000H, it implies that the very first instruction of the entire program is stored at the location 8000H. Next is EQU or the equate directive. Now this is used for defining a constant without occupying a memory location. It doesn't deserve a storage for a data item, but it associates a constant value to a data label. So if in throughout the program, whenever the label appears, the label will be substituted by the constant value. So here is an example. So at the beginning, if I define maize equate to 67, then throughout the program, whenever maize label is used, it will be substituted by 67. Next one is end directive. Now this indicates the assembler that this is the end of the source file. So it is usually the last line of a microcontroller program, signifying that it is the end of the source program. DB or define byte directive. It is the most extensively used data directive in the assembler. We use it for defining 8-bit data. So whenever we use this directive to define data, the numbers can be in terms of decimal, binary, hexadecimal or ASCII formats. It reserves specific amount of memory to the variables and stores the values specified in to that particular variable as the initial values in the allocated memory locations. The range of values that can be stored in a byte type of variables ranges from 0 to 255 for unsigned value and minus 128 to 127 for a signed value. Here is an example, data 1 db46. So 46 will be stored in a memory location which is named as data 1. Now 46 is only a byte which will be stored in that particular memory location. Data can be in the form of immediate operand, or it could be in a register, or it could be in a memory location, or it could also be a data from an external memory whose address is there in the data pointer. The method in which the data sources or the destination addresses are specified in the mnemonics that moves the data determines the addressing mode. That is, how exactly you are specifying the data in a given instruction is referred to as addressing mode. How exactly you are accessing the data is nothing but an addressing mode. So different addressing modes of 8051 microcontroller are immediate addressing mode, register, direct, register specific, register indirect, and indexed addressing mode. So over here the data is mentioned directly in the instruction. Data is stored in the register. Address of the data is stored in the register. Address of the data is mentioned directly in the instruction, and specific registers are used for holding the data, like say for example DAA instruction, decimal adjust after addition. For BCD addition, data is compulsorily stored in the accumulator over in that particular instruction. Register indirect, storing the address of the data in the register, and indexed is storing the address of the data in the register and using additional offset values or a data pointer for pointing to the exact location of the data. You can pause this video for a few seconds and watch the video mentioned in this URL to know more about 8051 addressing modes. A computer instruction is made up of an operation code called as the opcode, and it could have either 0 or 1 or 2 bytes of the operands. Opcode is the one which tells what type of operation is to be performed, whereas operands are the one where the source and the destination of the data are specified. The operand can be the data value itself, or it could be stored in a register, or it could be a memory location, or it could be from an IO port. If the instruction is associated with more than one operand, the format is usually in this way. You have the opcode, instruction opcode, the destination is specified for the data, and this is the source of the data. So after the operation is performed, the resultant data will be stored in the destination. Source operand doesn't get changed. These are the different 8051 instruction format. I can have just the opcode, for example DAA instruction. I can have opcode and the register which is being mentioned, opcode and a single operand, opcode with 11-bit address of the data, opcode and 16-bit address of the data, opcode and two operands. The entire instruction set of 8051 can be categorized into four categories. All the instructions can be categorized as data transfer instructions or arithmetic instructions or logical instructions or jump and call instructions. Data transfer instructions are mainly used for transferring of data from memory to register or from register to memory or between registers. Arithmetic instructions include addition, subtraction, multiplication, and division instructions. Logical instructions include bitwise as well as bytewise logical and or XOR, then complementing and clearing. Jump and call instructions include conditional and unconditional jump instructions, call instructions for calling the subroutines and returning back from the subroutines, then returning back even from interrupt service routines also. Pause the video for few seconds and go through this URL. It is a URL for a YouTube video which discusses about the different instructions present in 8051. Now that you have completed or you are familiar with what are assembler directives, what are addressing modes, and what are the different instructions available in 8051, take up a quick self-test. You have 15 questions listed over here. Read the questions and write down the answers in a sheet of paper. Here are the answers for the self-test questions shown in the previous slide. Since you have written it down in a sheet of paper, you can verify them.